Hello students, welcome to your favorite channel Science with Mukherjee sir. Today we are going to discuss a very important topic in haloarenes and haloalkanes, that is the physical properties of haloarenes and haloalkanes. In the previous some videos we have discussed about the classification, nomenclature and the preparation of the alkyl halides and aryl halides. Now we will discuss the physical properties of the. So in this video we are going to discuss the physical properties of haloalkane and haloarenes. So what we will discuss in the physical properties, first let us make a list of it. We first will discuss the boiling point, so in the physical properties we are going to discuss first the boiling point and melting point, in density, in dipole moments, bond strength and bond length, stability, solidity and infinity. All those physical properties we are going to discuss, and we will discuss how this is going to impact. What is the properties of the haloarenes and haloalkanes that we will influence for those physical properties. First, this is the boiling point. As the molecular mass is increases, you can write as so you can see as the molecular mass increases, the van der Waals force of attraction is going to be increases and the boiling point and melting point shall also increase likewise. So we can see there is three instances we can see. Number one instance, when the halogen is changing. So what will be the order of this decreasing the boiling point that we are going to understand. So this is the way you can see that boiling point goes on decreasing as we go from this iodide, alkyl iodide, then it is followed by alkyl bromide, then alkyl chloride, and that is your alkyl chloride. In this fashion, the boiling point will goes on decreasing. Here also you can see in case of aryl halide, this state is also we can find that with this halogen is changing, that when C6H5 it is having the highest boiling point followed by C6H5Br, borobenzene, and then it is chlorobenzene, and this is here chlorobenzene. So you can see how this boiling point is going to be increases, and this is why it is so. This is because the molecular mass is changing. When the molecular mass is changing, then the van der Waals force between the molecules is going to be increases, and it will going to impact the boiling point of the compound. For the alkyl group, alkyl chain, when it is changing, then what will be the order of decreasing the boiling point? So what is the order of increasing the boiling point? You can see here it is the longest chain of the longest carbon chain, that is propyl chloride, then ethyl chloride, and then methyl chloride. So as this chain is decreasing, the boiling point is goes on decreasing. So you can see here, as the side chain, number of side chain is increasing, then you can also find that boiling point is also goes on decreasing. As the increasing of the side chain, the boiling point is goes on decreasing. Here you can see there is a straight chain. Here is the chlorine atom in the side chain, and here also you can see the side chain is increasing, and here also you can see the side chain is goes on increasing. So when side chain is goes on increasing, then also you can find that the boiling point is going to be increases. So this is how the boiling point is going to influence in this case. For isomeric, we are going to discuss for isomeric aryl halides like orthodichromabenzene, or paradichromabenzene or metadichromabenzene. The paradichromabenzene this is the paradichromabenzene, and you can see there is a symmetry in the structure. The chlorine is at the corner of the both the places. Chlorine at the corner, and it is a symmetric arrangement. And this, due to the symmetric arrangement in the crystal, there is a good packing, orderly packing of these molecules, and it is going to impact the melting point, but boiling point is not going to be get affected by this. And the melting point is more than this paradichromabenzene. Melting point is more than this ortho and chloro. This is ortho dichromabenzene. This is paradichromabenzene and metadichromabenzene. In this case, metadichromabenzene. So you can see that melting point is higher. Melting point is higher in this paradichromabenzene as compared to the orthodichromabenzene or metadichromabenzene. Now we are going to discuss the density. Density you can see having this change. The density of the alkyl iodide, density of is the highest density because it is having the highest molecular mass, followed by RBr, alkyl bromide, followed by alkyl chloride and alkyl chloride. Similarly, you can see for different chain, different alkyl group, This also for different alkyl group, you can see the alkyl group is changing. Here that is the propyl alkyl group, here ethyl alkyl group, ethyl. So the density goes on decreasing. This is the highest density, it is at the highest density, followed by this. And when the halogen is increasing, number of halogen atom is increasing, this. So you can see that as the halogen atom is increasing, here chlorine atom is being increasing here. You can see this. So density goes on increasing, and this is CCl4 having the highest density. Okay, so we understand the density, how density is going to impact with the changing of the halogen atoms, with the changing of the chain. Next, we are going to discuss the dipole moments. How dipole moment is going to impact? It is basically the electronegativity. Electromagnetic negativity of the halogen is going to impact. So you can write this electronegativity. The alkyl fluoride will have the highest dipole moment, followed by the alkyl fluoride, followed by the alkyl bromide and alkyl iodide. But this is not the case. In case of this, there is a slight change in the order. That is, RCl is greater than RF, RBr, and the size factor. Here the size factor going to impact. Size factor of fluorine. Due to this very small size, of fluorine, in spite of it is having the highest electronegativity, but the dipole moments is lesser than the RCl, because the size outweighs its electronegativity. Okay, so this is how we can see the dipole moments for the alkyl halides. Now for isomeric compounds of the aryl halides, para-dichlorobenzene, this is a para-dichlorobenzene, its dipole moment is 0. Its dipole moment, you can write dipole moment of para-dichlorobenzene is 0. But meta and ortho is having the dipole moments, and this dipole moment depend on the angles between the two chlorine atoms. And for the ortho, it will be having the higher dipole moments than the meta. So we write this way because of the angle between here, the angle between the chlorine, two chlorine atom is 120, and here it is a 60. So according to the law of parallelogram of your resultant dipole moment, so you will calculate here that it will be having the higher dipole moment than this. So this is all for the dicomboments of alkyl halides and aryl halides. Then we go next to the bond strength. You can see that is RF will have the highest bond strength followed by RCl, RBr and R, because the bond length is lowest in case of alkyl fluoride, and that is followed by alkyl chloride and alkyl bromide and alkyl. In a similar fashion, you can see the stability. Stability will have the same order. This RF, that is alkyl fluoride, having the highest stability, and alkyl iodide is the lowest stability. Even if we keep the alkyl iodide in the sunlight, it will decompose into an ion. In the sunlight, simple sunlight, that you can find that it will decompose. And iodine is dissolved in the ion and it will give a deep blue color. For the solubility, you can see the alkyl halides or aryl halides, they are insoluble. Insoluble in water because they do not form any water hydrogen bonding. So we can write this: not dissolved in water, because they do not produce any hydrogen bond. And last one, that is the inflammability. As the halogen is incorporating in the hydrocarbons, its inflammability goes on decreasing. CCl4 is used as a fire extinguisher. So it is seen that the corresponding hydrocarbons is more inflammable as compared to the alkyl halides from this hydrocarbon. So that is all for today's video. We have discussed all the physical properties, how they are going to influence with molecular weight, with their different types of bond polarity and all the things. That is all for today's video. Thank you for watching, and okay, all the best. We will discuss the chemical properties of the alkyl halides. Okay, thank you.